I think she started. So again, yeah, this is the Filecoin Orbit Austin Meetup group. My name's Dante, and I'm one of the main organizers. There's two other organizers that are here today. We meet every third Tuesday of the month, so we're here every month. And we put all of our slides on GitHub, and we have a website. It's Austin Orbit, sorry. Yep. So this is our website. The link to the GitHub is there. Yeah, you can check the calendar. And yeah, we'd love your feedback. If anybody has topics or want to give a talk, definitely contact us. We have a Slack channel too, which I'll share. And oh yeah, thank you to our sponsors. So this is sponsored by Filecoin Foundation and Capital Factory, and also my company Konvergence. We build Web3 data systems. And so today I'm going to talk about hole punching in IPFS. It's a little bit different than your standard hole punching. Like most, I would say, IPFS or like distributed systems, it's a lot more complex. So we'll talk about standard hole punching. Basically, what is hole punching? Basically, if you've got a server that's behind a firewall or it's behind a router in your house that offers some kind of protection, if a random router tries to talk to it and it doesn't know it, doesn't trust it, it's going to deny that connection. And so again, there's kind of two kinds of internet. There's public internet where anybody can talk to this server and there's no firewall and you can get bombarded with spam. And then there's private where usually there's some kind of NAT or a firewall in place, and only certain ports can communicate with other routers or computers, right? So hole punching allows two private servers to talk to each other, at least one of those being private. And again, when you have kind of a standard server environment, usually you have a public-facing IP address, and then you have an internal IP address. And when you open ports on that IP address, you basically usually do some kind of mapping between the internal IP address and those ports to the external IP address and those ports, right? And again, a lot of the times you will have a firewall. Sometimes that firewall won't be in your control. So you might be using like a hosting, Amazon or Google or whatever. They have like their own system. So when you're talking to that public IP address, you're not actually talking to that physical machine with that IP address. You're talking really to some kind of abstraction that Google or Amazon puts in front of it that routes it, and that's where, again, once you get into IPFS, it creates all kinds of complexities. Interesting thing about IPFS is there's multiple versions of that too, right? There's public IPFS, and public IPFS, anybody that connects to that is using the same pre-shared key. So everybody basically has access to that. If you change that pre-shared key, you're suddenly on your own private IPFS. And that means that IPFS can't talk to the public IPFS or any other IPFS, right? It's its own private network. So in a private IPFS implementation, every single node needs their own IP address, right? Which is, can be an issue. but also because you have to like open certain ports on there and they have to be able to communicate. IPFS nodes have to communicate peer-to-peer. If you try to implement like a private IPFS network on Google or Amazon, it's probably not going to work for you, because again, they have their own kind of routing in front of the IP address, their own firewall and whatnot that you have to kind of navigate around. So yeah, it gets very, very complex very quickly. But hole punching is something that I think a lot of people in the IPFS space have, been wishing for a long time, and there are some interesting ways to do it now. But again, your standard hole punching would use something called a 5-tuple, which kind of looks like this. It's let's say you have two servers that are trying to talk to each other, A and B. Your 5-tuple consists of the IP address for A, the IP address for B, the TCP protocol port, and the ports that they're going to communicate over. Basically, for like standard servers, all that really needs to happen is router A sends a packet, like computer A sends a packet to router A, right? And then router A, in that packet, you put a header you put an IP header basically in the packet that contains this. This assumes that you already know the other server that you're trying to talk to, the IP address of the server and the port that you want to talk to, right? So assuming you know that somehow, basically you can send a packet with this header that has this, this data, and then that router will basically log them into basically like a whitelist where, it says, hey, this server, I'm trying to talk to this server, and if you get a response back from this server, it's cool, basically, right? And so router B does the same thing. If they send packets even at the same time, by the time they get to the other router, that 5-tuple record will exist, and then it allows, it basically does all the mapping for them from the public IP address to the internal IP address, and it lets your router communicate directly with this other router or computer or whatever and send those packets through. But both routers have to send this 5-tuple. Decentralized hole punching is way more complex, right? Basically, so there's a whole preparation phase that has to happen. In decentralized routing, one of the main reasons for the complexities, nodes can go offline, right? And basically, there has to be some way of syncing between the nodes, so like everybody's kind of aware of what kind of latency they have and like what the structure of the network looks like. The way this is done in decentralized systems is using, or the way it's done right now, I guess, is using relays, which is kind of an interesting way to do it. It's pretty costly in terms of the amount of traffic that you have to send back and forth. But it does get the job done. It allows you to hole punch. So basically, again, it's kind of using this separate layer that everybody, again, a public layer that anybody can communicate with, as a means to forward your packets to the other system that you're trying to talk to. And then once basically once that connection is established, basically, router A to the relay and router B to the relay, and then talking to each other through the relay. Once that's established, they can basically do like a handshake and create kind of that whitelist that we had before to just get rid of the relay and talk to each other directly. And that would be way more efficient. But again, it's not easy for a lot of reasons. IPFS has a lot of, has different ports that it communicates over. If you have multiple nodes running, you might be using multiple ports for, different kinds of communications. So, basically, again, I'll just go through this pretty quickly. There's a preparation phase, which essentially, in this example, router B is, you're trying to determine whether it's even dialable, whether the relay can even communicate with router B. Or really anything can communicate with router B. If it can, like that's public router, anybody can talk to it, right? But if it's not, then you have to communicate through this relay node. So router B has to basically register with the relay node and say, okay, like I'm using a firewall, right? I can't advertise, my public IP address because it'll drop all those connections. So I want to communicate through the relay. So basically, here's my IP address. I want you to listen for incoming, connection requests for me, basically. So each router would have to basically register with the relay and talk to the relay and establish a connection. So that's all that's going on here. They're establishing a connection with the relay, and then they're requesting what's called a reservation, which just means like put me in your lookup table. Put me in your lookup table to basically accept connections for me. And then if the reservation is accepted, then the relay will be kind of listening for any connections trying to, get through to this other router. Okay.
So the question is, once, you go through the relay whole, dance, whatever, does the relay then give, I guess, the public your IP address once it's requested? Or does it, filter all the network through the relay?
Yes.
To hide your IP address?
Yeah. Yeah.
So that adds latency, right? And if there's a lot of people on the relay, you're gonna be super delayed.
Yeah, the relay nodes have to be super high bandwidth because they're gonna get hit with a ton of requests because anybody can talk to them, and they can also be spammed and DOS attacked. But so right here, so for each of the public relay nodes discovered, registered. Basically, first B connects to the remote node, requests a so-called reservation, basically says, hey, I'm not dialable. Given that you are dialable, would you mind listening for incoming connections on my behalf, forwarding each of them over to me? So once the reservation is accepted, basically, it creates this multi-address that is the IP address of the relay, / P2P circuit, and then a peer ID. So the peer, is stored in some database table that maps to their public IP address. But the thing that they're actually advertising to the network is the relay's address, right? So that multi-address is, or the machine's actual IP address is hidden from the rest of the network. And basically, if the remote accepts the reservation request, then B can advertise itself as being reachable through the remote relay node. That's basically what I just said. This is, again, kind of the format of the multi-address. And yeah, this is important. It's important that B keeps the outgoing connection to the relay node alive. B is not publicly dialable, thus the relay would not be able to establish connection to B. So, yeah, essentially you have to keep that connection alive. Another reason why it's better for these kinds of networks to have like actual servers instead of computers that turn on and off. Yes, so then what happens, this is the first step of the hole punch. Let's say, so basically both, A and B have to do this dance with the relay. They have to register with the relay, establish connection with the relay. And then it says here, before establishing a direct connection using the hole punching, A first has to establish a relay connection, and then, so a relay connection to B via the public relay node using the information contained in B's advertised address. A first establishes a direct connection to the relay node and then requests a relay connection. The relay forwards said request to B, which accepts the request. The relay once more forwards the acceptance to A. From now on, A and B can use the bidirectional channel over the relay to communicate. So like, this is kind of the first step of the hole punch. You're still using the relay, but they are able to send packets from A to B, basically. And then there's another like dance that they have to do here to actually punch the hole. So what actually happens here too is once they actually establish connection between A and B, they upgrade that connection. This upgrading is you upgrade to a TLS so that that communication is encrypted now instead of just all public. And then kind of the last step is basically both A and B have to send a connect request they send it over the relay, over TLS, and they send in that connect request, that's where they send their actual IP address, right, to between the two, and the port number and whatnot. They make sure that each of those machines is sending that connect request, and then each side is receiving it, has received it. And when they do that, also they're testing how long it takes to receive the response from the other one, so they know kind of the latency between them. And then basically once the final step is that they send this it's called a sync request. They send the sync request half of the time it takes to get the connection back. Basically half of the latency time, it waits that amount of time and then it sends a sync request. And both sides do this. And then it says here, A sends sync message to B on the relay connection. Once sent out, A waits for half the round trip time, and then it dials via the address received in B's connect request. So this is a direct dial using, not using the relay connection. On the other hand, as soon as B receives A's sync message, it immediately directly dials A with the addresses provided in A's connect message. So that's the final step for A and B to establish a direct connection without the relay. And then the relay just drops off because you don't need it, right? And now these two nodes can kind of remember each other and always talk to each other. Yeah, again, how complex that is probably oversimplification because, especially with IPFS, every node is like hosted on a different environment, and And it really depends, like, who's administrating over that, so it can get way more complex. Recently, there's some pretty interesting kind of alternatives that also use relay networks, but are kind of aiming at being more efficient than kind of your traditional Kademlia, like DHT-based system. Just gonna play a little bit of this. Pretty
what
interesting.
I'm going to talk about?
She has a.
Is the DHT the same stuff they had back in BitTorrent days?
Pretty much.
Distributed hash tables?
Yeah. Pretty much. I mean, it's been upgraded for efficiency, but they're actually trying to get away from the Kademlia DHT to even more efficient systems. I think they touch on some of that here. She has a pretty interesting visualization of kind of these handshakes going back and forth between, again, the like A and B machine and the firewall, basically the NAT server, and what else? Something else in this architecture. And again,
So just to give some, we've yeah, okay, so you want to, should I share?
Who is this
So
person?
just to,
okay, so her name is Ramfox. She, I think she's the CEO of IRO. It's a hole punching network built on libp2p. Again, she's trying to make this whole process more efficient and more scalable. And this is, again, just an example of the handshakes that have to happen between these two servers trying to talk to each other.
to give some context here, we have two NATs, they're mislabeled. This ends up, the get NAT here is actually the NAT for the serve side. And so this is the serve side NAT and this is the get side NAT. And then this is our
What do you mean
that's
by,
our
sorry,
sim.
can you explain what you mean
Oh,
by?
let me give you more context. Let me give you
Okay,
more
okay.
context. So much more context. This is IRO under the, with this structure. There is a provider that is a longer running provider. This isn't always this isn't every scenario that can happen, but this is just this scenario. There is a long running provider that is expected to be up and running that is serving some content. And it is behind a NAT. Then there is some node that wants to fetch that content. This node spins itself up, does all of its connection gloriousness behind its own NAT, and then requests data from that provider. So the provider in this case is called SRV, so the serve side, and then the person who's getting is the get side.
She's gonna play this in full.
Shall I continue with this? Any other
Please do.
questions? Okay, so what is this? So the order that things happen right now is the serve side attempts to talk to the derper and it does it through the NAT because the derper has a public address, so it lets.
The derper she's talking about is a relay node, basically. I'll show you kind of the system that they're using.
Can I ask a dumb question real quick?
Oh, yeah.
What in the world is NAT?
NAT is network address translation. Basically, that's the thing that does the mapping. So if you have like a whitelist, you say like close. It's basically a firewall.
Okay.
Close all connections to the outside world except those coming from this IP address and this port, right? Trying to talk to my IP address and this port, right? And so it's a mapping network address translation, and it also, I believe, basically translates the internal IP address to the external IP address.
Yeah. It's like if you have a family of children, the father says the NAT, and you want to talk to the children, but you go through the father, and the father will say, like, oh, this is for child A, I will give it to child A, right?
Got it.
So you never talk to the
He's
children.
the conduit.
Yeah, he's the handler.
Yeah.
Yeah.
Thank you.
Yeah. And that's a very common thing across standard.
I'm still
networking.
learning language. I mean,
Sure.
I want to learn it all, so I'm.
It's stored locally, either say your home router has a NAT table, also then your provider has a NAT table, even
Okay.
global telco providers have a NAT table, and when a data packet goes out, you have the internal IP of the data packet. When it leaves, it gets assigned the external IP, so that way when it goes out and comes back, it knows what to come back to, like in that case, child A.
And it protects the internal components.
Yeah,
And
you
that's
can't.
and that's basically why Facebook went down for like a whole day, like 2 years ago or something. I don't know if you remember that. Facebook went down because basically the key that decrypted the NAT tables was like reset or something, so none of the nodes were able to read the NAT tables, so they couldn't talk to the rest of the network. The infrastructure didn't go down, the servers didn't stop spinning. It's just they didn't have the key to decrypt the mapping, right? So
Is
none of
the
them could
NAT
talk.
the key too, or is the key something, a different term?
The key is like if you encrypted that it's basically a database, right? The
Right.
NAT is essentially a database.
Okay.
It's a mapping of one IP address to another one, and it's again that's the thing that he's talked to. Instead of talking directly to that IP address, he talks to the NAT, because what if that other IP address changes, right? It would just update the NAT, and so you're always talking to the NAT, and if something changes on the other end, the NAT will know about it, right? But in this case, Facebook's case, the NAT didn't know about it. It took down the whole network for like, I don't know, 24, 36 hours. Yeah, and I think actually something similar happened to Microsoft Azure a little while ago.
It is not behind a NAT, so it's left.
Another thing here, if you see on the left here, the different colors are different protocols that these servers are communicating with. So TCP, that's kind of your standard. HTTP, Quick is HTTP3. That's kind of the new standard they're trying to push. UDP is like the standard protocol that most routers use to talk to each other. But you see like they're using a lot of different protocols basically to do these like handshakes. And what you're seeing is ping pong basically. So pinging the server, waiting for the response.
It's letting communication through. And what you're seeing here is like TCP, some of it is a stone request, but the first round was a stone request. Now you're getting the TCP handshake, the TLS handshake, including chatter between the derp client, which is inside the Magic Sock, and the derp server. So it's setting up its own relationship, saying, hey, I'm connected to you, keep me alive, I'm valid, I'm not a bad guy or whatever. And that's the chatter that you're seeing here. We don't currently leverage the TLS. There's a lot of stuff in TLS to make there be fewer packets that are being sent that we are not currently doing, but that is on the list of improvements. So that's all this chatter that's happening. Next, the get side is setting itself up. So it is now making stone requests, which get sent to the derper and then does its own TLS
Here's a question.
handshake with uploads. Yep.
Why is the NAT? The NAT says IRO serve 0, but it seems like this is the NAT for.
Yeah, those are mislabeled. Multiple derp servers that are meshed that can act. Is it a part of bound SIP, or they the different pings that we get? So also, okay, sorry, let me do this a little slower because this is actually
You
really.
can see like how complex this really is, just in her like the inability to explain all of it kind of in one.
So it is just trying to punch through the NAT by directly talking to the server side. And it's accompanied by these TCP messages that are the disco messages saying, hey, try to contact me here. We got some more chatter.
Pretty soon they're gonna hole punch. We'll see.
Let me go a little forward here.
There's so much communication back and forth. This is why it's very costly. Like, there's
Okay, so we finally hear
a lot of communication that has to happen. And they're working on making this way more efficient, which it
Again,
could be.
a message through from the derp server. It went from the get side to the derper to the server. And now the server side is sending all of those pings on all of the addresses it now knows from the get side.
There's the
And then
punch,
the quick connections can happen.
basically this quick the red balls,
And it is hole punched.
talking directly to each
Wow,
other.
so cool.
Yeah, so it's a little,
So
But her implementation still has a relay. That
it does.
So
It does. Yeah.
I've been doing this a long time. I've never seen anyone solve it without a relay. You always need a relay.
Pretty much. Yeah. The key
Verify
is,
that,
I think the key is to like make the relays more efficient. So that which they're starting to do. So this is actually the relay that she's using. It's called Tailscale. With these derp servers, basically they've got, it's almost like a CDN. They've got these servers, like high bandwidth servers set up all over the world, and they have a service that you can pay for. If you want to really push bandwidth at it, it's like $18 per user per month or something, which is interesting. One of the, I think, Protocol Labs people in that video brought up this other system for basically what she's doing is multiplexing, right? It's just trying to talk to any available, address that you can. He brought up this system called MASQUE, MASQUE, which is essentially a system to do the kind of multiplexing or the relays. So if you want to host a relay node yourself, you could basically implement the MASQUE protocol. What's pretty cool about it is it uses HTTP 3 and the new, well, it's not super new, but the quick transfer protocol, which is basically meant to replace TCP/IP. Quick is also, I believe, encrypted. So this is kind of nice that, once the quick connection is established, you basically have a super secure connection. This system also allows you to multiplex. So again, try to talk to any available port, any available IP or different protocol.
It's still costly though.
It is.
But they probably start with EDP and then establish.
Mm-hmm. Yeah, and then upgrade. But what's nice about this is this is open source and you can run it yourself. So you still have to pay for it, obviously, to run the servers, but you can control it a bit more. So yeah, questions about hole punching and IPFS.
I mean, it's worth noting that you highlighted the important part is like, okay, for running IPFS, the goal is to always use excess laptop space, which is a harebrained dream in my opinion. But if you are just using a DIA circuit in the internet, none of this applies. It doesn't matter,
100%.
right?
Yeah.
Like when people were running Bitcoin mines at home, they had
Mhm.
problems with this, right?
Mhm.
But now that it's all three main providers with
Yeah.
associate providers,
Yeah. Well, and here's the
Filecoin is really only about 400 providers.
Mhm.
Really just shave off the
Exactly.
Chinese IPs.
Yeah. Well, what's interesting about IPFS too is I believe they've figured out how to make it efficient enough to run a relay where basically every IPFS node is a relay node also. So because if you're trying to hole punch, which also assumes that you already know the address of the server that you're trying to talk to for some reason, which with IPFS, ideally you don't have to know the address of the server. You could just get the CID and ask the network, whoever has the CID, right? But if you do need to hole punch, which actually does come up a lot.
Well, yeah, every time you turn up IPFS desktop, you have to hole punch.
Right? Yeah. Basically, you have to contact one of these relay nodes, and so you use the DHT to figure out where the closest relay node is. But with IPFS, there's a lot of them because there's a lot of nodes, and they're all basically able to be relay nodes. So that's kind of nice. It's easy to find the relay nodes. But it definitely does create a lot more chatter across the network that takes up resources. One of the things that my company is working on, again, from a kind of Web3 protocol standpoint, again, we believe that every user should own their own data, right? So we think that where they should store that data is on their own server that they rent basically from a hosting provider. If you give every user a node, which includes an IPFS node, right? But it's just a server that's running all the time, you can solve so many of these problems. The majority of the issues in the IPFS space, when people talk about, I requested this file and it took 20 minutes for the network to figure out where it was and return it to me, right? That's a common thing that happens in IPFS. People say it's just slow compared to the traditional internet because it has to talk to all the peers and it has to traverse the DHT and figure out where this content is and then it has to come back, right? Well, the real issue there is that there's not enough nodes in the network, right?
There's not enough robust nodes.
Well,
right.
Yeah, but also like it's distributed, but then it's only so many.
So distributed, yeah.
Like it's like the opposite of BitTorrent, where every single kid, or like Napster, right? Like you have your computer, there's millions of people.
Mm-hmm.
Here it feels like
Right.
there's a small pool and there's huge delay. So it's like it's a lose-lose almost, right?
Yeah, the node to user ratio
Yeah.
is way out of
Yeah, it's
out of
not.
control.
Yeah.
So again, my solution to that is give every user a node. Yes, they're
That's
gonna have.
expensive.
Not really. I think you could do it for what you pay for like Spotify subscription a month, right? The thing is about a node, like you think about the internet and like all the different subscription services that you pay
No,
for.
you're right, but like the end user doesn't want to pay an extra $10 to use IPFS.
Okay,
But
but they want to pay $10 to use Spotify, right?
Correct.
And they want to use $10 to use like Google Drive and or Apple iCloud, right? To pay for the storage on there, right? They're paying for the same thing. With
No.
Spotify, half of your Spotify subscription goes to a server, basically,
Absolutely.
right?
I mean, if Apple said, "Hey, you choose between our cloud and IPFS," of course that would make sense. Like I would pay even $20.
Well, that is the
The end goal, right?
That is the decision. That is it. But
it's not, right? Because Apple cloud is so integrated, yada yada yada. That's why you pay the big money, right?
well, but there are, so going back to regulations and the ownership of data. If you look at Europe and how they've come into effect with certain regulations,
Right.
there's a cause and there's a governmental push that could, let's say it
Mhm.
will, but there might even be government funding to push IPFS to become and to support the application of those nodes because
Yeah.
they're trying to bring back any
Yeah.
kind of, like, the major servers are not going to be able to connect anymore. Like,
Mhm.
there's massive
Yeah.
pushback, at least
So,
from my coworkers over there.
yeah. A couple other things I'll say about that. If you own your data, you could also monetize your data, right? So you can sell it to the advertisers yourself and make all that money, right? So there is ways to offset. Also, your node, while you're sleeping, could be doing all kinds of other work that you're getting paid for, right? So there's ways to offset that cost. But also, like, another good point, I think this is kind of the perfect place to store secure data, like medical data, and that kind of data, and peer-to-peer communication between, like, your doctor and like your smartwatch or whatever, like, monitor you're using. I think that will be subsidized and potentially even regulated to make it required, but they're going to pay for it because it's going to save them billions of dollars in, like, Medicare and Medicaid, right? That's my opinion.
I mean, I think that it doesn't look to me like big tech won't just adopt something like IPFS and sell it to you.
Yeah.
I can say that because we are trying to close deals with large tech companies to adopt IPFS and Filecoin.
Yeah.
And the business models that come out are great, sure. It's going to cost you more to store with Google, but they're going to containerize your data. And you can export it and they'll legally guarantee that they haven't sold it.
And it protects them.
It'll cost you more than, $5 a month. It's probably going to cost $15
Mhm.
if so you
There's
choose that.
so many reasons to.
$5 a month per terabyte.
There's so many
It's
reasons.
like
I
the
mean,
clearing price right now.
plus, like, I would say, like, a certain, you only need, like, a 4-core server, and, like, what? The average person has, like, 200 gigabytes of data, right? Max. Like, your phone is only, 64 or whatever, 32 gigs. Most people don't have that much data. I think you could buy for, like, $50 a month right now with the major hosted cloud companies. You could buy a server, it'll spin up in, like, 5 minutes for, like, $50 a month. But that's in a market where there's no consumer demand for that, right? Once you get consumer demand, that price is going to go way down. As the chips keep getting better, that 4-core CPU is going to cost basically nothing. So in 5 years, I think this is going to be like $5 a month or something, right? Yeah, it'll be negligible. You'll be able to offset it, but also, like, the time you'll save. The money you'll save actually on these third-party subscription services, you only have to pay for that hosting and that storage once. You don't have to pay for it 5 times if you subscribe to 5 different, providers. But if all your data is in one place, like, think about QuickBooks. The only reason people use QuickBooks to do your taxes is because it lets you link your bank, your credit cards, everywhere that you basically spend money to put into one place, so that then you can, like, manually, classify it and do your taxes. If it's already in one place, if you store all of your data in one place, you just have an AI do your taxes in, like, 5 minutes, and it's like, cool, you're done. But you can't do that unless it's all one place, right? So I think the time saving, you can have your own private AI assistant, like, do your shopping for you based on your previous behavior or whatever. If it's all in one place and you're paying for that, you're going to save time. People are going to want to pay for that, I think. But again, if every user has a node, 99% of these, like, crazy hard architectural issues in Web3 will be solved, because there's more than enough resources, right, to get you a response to your query fast enough without clogging up the system,
That makes an assumption that they're geographically distributed, though.
Yes.
Like, what's going to happen is, like, somebody's just going to have a cost structure where they're all going to end up in North Dakota,
Well,
or somewhere there's cheap power.
The way that we're doing it, when you sign up to Cloud Forest, we spin up actually 2 nodes for you. Both of those nodes are hosted by different storage providers, and they're in different geographic locations. And they actually sync using IPFS. They sync the data back and forth in real time. So if one of them goes down, you still have a backup, right? In the case the entire cluster goes down, you have all your data backed up on Filecoin. And that's what I think Filecoin is, definitely a really important aspect. But I think, again, if you've got those multiple nodes, like think about that. Even if you're sharing, you could share those nodes with multiple users too, right? Like you could probably fit, I don't know, 3 to 5 users per like 4 CPU node. Let's say then the ratio is 2 to 5, right? 2 nodes for every 5 users. That at scale is like way more, like you couldn't fit that many nodes in one location if you tried. Like they have to be distributed, right? And that amount of demand, there's data centers all over the world that are like dreaming of selling all their space, right? There's no consumer demand for cloud servers, right? If you create that demand, the hardware's already there, and that ratio of users to hardware, it's going to make the internet way more faster, way more efficient than we currently have right now. And then the data issue, again, I see that as the only way to protect yourself from AI, right? Like, if all these third-party companies, own your data, like, how do you know that you're not being influenced one way or another, like, based on some news feed that's being populated that you can't control, you really don't know. And if you want to protect yourself from AI, you gotta own your data.
Right? It's complicated though, because then you have people that don't care about, like some sort of like their privacy, that now have access to AI that can work for them. And then you have the people who are like privacy conscious, that own their own data. They don't have access to AI because it's not trained on their data, or they're playing in a different field. So it's almost like guns versus knives, right? If you think about it.
Yeah.
So like then, is it worth having guns? And if you give up your privacy, like access to your data, or would you rather be stuck with a knife?
Depends on if you're close enough. Knives are more effective if you're closer. I'm just being funny.
Sure.
Yeah.
Or trying to.
There's a really good joke in there about bringing a knife to a gunfight.
Sure.
Yeah, exactly.
I think the idea to containerize your data is out there. I think IPFS is a potential solution. I think it's a better solution, to be clear, for medium-sized enterprises. We see a lot of traction there, right? Because they have the resources internally to tinker, and then we can guide them accordingly in some type of pro services engagement, whether that comes from Filecoin Foundation or an ecosystem participant. But the individual, they can download IPFS desktop, but a lot of times it fucks up your local LAN, and you have to reset your router because it floods the NAT table. So,
yeah, logs can. You don't have enough data to store the logs.
And WorldCoin takes what do they do? Take a picture of your eye? No, I just saw that. This stuff.
I mean, that's a bit different, but yes.
But the containerization aspect too, I don't know how you would read and write against this container across multiple services.
Right, but you're saying that you're selling, or whatever your company, someone is selling an IPFS solution to mid-sized companies. So instead of storing their data on like GCP, Azure, or AWS, they go to IPFS.
And specifically because they want an easy way to replicate data, but also have content addressing in an easy way to basically retrieve an indexed file, right?
Okay.
Yeah.
It's like a signed URL, right?
Yeah.
So think like object storage, you have to manage that index. Like IPFS makes it pretty easy to manage an index of files.
Yeah, I feel like it's kind of niche, but maybe it's not. I mean, I don't know.
Scientific use cases are really high. There's military use cases too,
Yeah.
because of the
Also,
like IPFS on a private LAN is very powerful, right?
Yes.
Because it's not dealing with all this hole punching bullshit.
right.
But if you need nodes in like disparate regions, IPFS is your perfect file store for that. Especially if the LAN is somewhat, call it 100 milliseconds latency and it's 99.9% uptime.
Yeah.
IPFS works perfect for that because it's really good
Sure,
at
it's
syncing.
self-managed, right?
Exactly.
Right.
And again, like Google.
And that wasn't the original product design. The original product design was for people to
Yeah, share stuff.
share.
Like,
I don't know,
if
whatever.
you own a bunch of IP, you want that IP to be backed up by multiple cloud providers, right? A lot of these big companies, they have one cloud provider, and then they have to deal with their backup to that cloud provider is a bunch of this like tape or like physical storage,
Yeah.
Or they don't back it up because they can't afford the
They
ES
have-
fees to send it to another
Most of
provider.
them do, right? So, but they can't have two cloud providers because Google doesn't talk to Amazon, and their NATs don't talk. You can't hole punch between them, right? If you wanted to. So
I'd argue that's not true. I had a call in 2 hours with Console Connect.
they're using a
Solve
relay.
that problem.
They're using a relay,
Yeah. Console Connect.
and that's what we're talking about,
Megaport
right?
and Console Connect.
It's a relay. This system that I'm gonna load here, it is hosted right now with two different cloud hosting providers. There's no relay. It uses IPFS peer-to-peer directly. Oops, I can't log in. And again, yeah, you don't need relay. And as soon as I uploaded, I wish I could show you those servers, but I can only log into one of them right now. If you upload a file here, and another user is logged in to the other node that's on this shared IPFS network, it's really quick. As soon as I upload that file, it syncs. The CID syncs between the database, and then the node does a fetch request from IPFS. It pulls the file down, and now you have two copies of your data that are verifiably the same binary, right? Because the CID would be different if it wasn't. That's the great thing about IPFS. And that's the other thing that these big, especially the IP owners, care about is they need a checksum to make sure that the data that is being stored is the same data that they uploaded, and then they need to replicate that in two geographic locations, ideally with two different hosting providers, because like again, Azure goes down, and one engineer like deletes a key and like the whole network goes down, right? My point is the IP, the content creators are the people that are the entities that most of us use the internet to go access their content, right? They're the main stakeholders. If they decide that everybody should be accessing their content through, IPFS or this kind of system, everybody will, and you'll pay for it, just like you pay for HBO Max or whatever it is, right?
Sure.
And that's my point. It doesn't matter if people want to, because the content creators have a vested interest in doing this. But not only that, how many of these companies wish that they actually owned their Facebook page and their followers on Facebook, right? And that they could advertise or they didn't have to pay to reach all those people, right? Like
I know, but the devil's advocate would say, okay, name 10 people, artists that have their music on IPFS exclusively.
not artists.
I mean, that's an example, right? Content.
All it takes is one movie studio, or they're all Universal. Let's say
That's
they.
one studio, right?
Yeah, they own like 90%
No, but
of the
today,
music
I'm saying
industry.
no one uses it. That's the point. There's no adoption yet.
No.
So the problem is with the adoption.
Why is there no adoption?
Well,
Because there's
to
no
be
node.
clear, IPFS is not
something you should be storing anything like that. Filecoin would be. They're two independent networks. There's no incentive layer to run IPFS nodes. It is just,
That's true.
the way we look at it, so you do a DNS query on Google, right? Who pays for that? Google pays for it. Now, if you do it on 1.1.1, Cloudflare claims that they don't store your data, but they're subsidizing it. We're doing the same shit. And the only reason we do that is because IPFS is a good primer piece of technology. It's free, it's cheap, it's easy to use, and it teaches people content addressing. Filecoin is hard to use, expensive, but it has an incentive layer that still needs some tweaking. But IPFS was meant to be released to the world. We maintain some of it, and then there's all these people trying to fix it because there are a lot of people running it in private LAN environments.
Yeah.
That's where I think it works really well. I think from a public setting, there's a lot of use cases that I don't even know about, but in general, I don't touch it. It's all.
Well, IPFS is used by, Bitcoin was using IPFS, I think for the first 5 years or something.
Yeah.
I mean, that's a lot of, that's a pretty large market cap.
Ethereum uses LibP.
Ethereum uses IPFS. Everybody that uses Ethereum uses IPFS. Anybody that creates an NFT uses IPFS. A lot of people use IPFS, right? But again, it's not the main reason people don't use IPFS is there's not enough nodes in the network. If I'm a content creator or a giant studio, right, and my only issue is there's not enough nodes in the network, well, I'm going to start handing nodes out free to anybody that wants to watch my movie, right? Or, so I'll either subsidize it or somehow create the incentive for people to start buying these nodes, right? And if I do that, then there's enough nodes in the network, and then you have a way faster system that's way more profitable for them, right?
But that takes the profit margin, or that takes the profit away from
Google,
the bigger players.
Amazon, are they big?
Ultimately, what you're advocating for flips the entire
It's
fiscal
an
dynamic.
inversion.
Yeah, it's a complete.
It's an inversion of the data ownership. But who do consumers like more? Their favorite movie stars or Google? Who do they care about more? Right? Their favorite musicians or YouTube?
Yeah, but they don't have the education to understand the difference.
It's not them that are gonna make that decision. It's the content.
Basically,
creators,
what you're saying
right?
is like if Billie Eilish and Dua Lipa and everybody decided, all my music is stored in place of some distributed file system, then you're saying everybody would pay to access it and therefore give back to the network. Sure, that would be great.
Well,
Full stop.
it happened with Spotify, right? It happened like Universal bought into Spotify, right? They own a large portion of Spotify. Same thing with
They still have to pay Spotify.
what's the one with Jay-Z?
That title. But
Tidal.
Spotify still has to pay the labels, right? For the music streams.
Well, they are the labels now, but yes, they do. But they barely pay out. Why? Because bandwidth is expensive, because the current HTTP model is very inefficient, right? If every one of their users had a geographically distributed server that is a CDN, and they're paying, for that CDN, guess what? If you hit 1 million views on as opposed to right now, if you hit 1 million views on YouTube, YouTube's paying probably $100,000 or something, or a standard cloud provider would charge you $100,000, right, for millions of views on a 4K video, right? You would get hit with a bill. That's why you use YouTube, right? But then they take 90 or 95% of the ad revenues, which could be way more than that $100,000, right? That could be millions of dollars.
Yeah.
In your model, that could just be its own IPFS network.
Yeah.
It doesn't have to be. IPFS is a tool.
Yeah.
Even though we call it a network, there is a public IPFS
No,
network.
I think IPFS by definition is a network because it is you have to have at least one peer That's the one thing about IPFS. If you only have one server and there's no peers, it doesn't do anything.
I understand that, but I'm saying that Universal could run its own IPFS
Yes,
network, right?
absolutely.
With its own peers,
Absolutely.
its own.
Yes, but if they wanted to talk to another IPFS network with a different pre-shared key, they would have to hole punch. Yeah.
Like I think IPFS will outlive a lot of the other Web3 tech because there's so many people that have implemented it.
I agree. Yeah.
It's been around for a long time.
Yeah, 2014.
It has. I mean, okay, it's why blockchain exists, in my opinion. I mean, a large reason why. It's based on what, like the standard Tor, onion routing. So that's been around.
The Chinese have taken it and injected it with steroids.
Mm.
The stuff I see in China with IPFS is unreal.
Mm. Yeah.
Fairly large corporations using it.
Yeah. It's basically onion routing, like way more efficient, and with CIDs. I mean, CIDs are a game changer. Implementing the DAG, that way of taking the binary. So if one little bit of that file changes, the CID changes. I think that's a game changer. Again, who cares about that? Whoever owns a copyright, they care about it. And that's who gets 90% of the traffic on the internet. And that's why I think Web3 IPFS is going to happen.
I mean, CIOs care about that. They want to know their data is unique.
Yeah.
If it is unique, they want proof.
And by the way, just for the live stream also, we have a survey. If anybody wants to give us feedback or has a topic that they want to talk about next time, usually it's not just me up here talking the whole time. But yeah, thank you guys for coming in. If you have any other topics that you want to talk about, basically open floor. So.